You ever stop and think about how your computer finds one specific website out of, billions? Or how your phone just streams a movie from a server that's halfway across the world? Well, it all boils down to this one super important idea: an address. It's kind of like this invisible system that makes our entire digital world work. And today, we're going to pull back the curtain and see exactly how it's done. Alright, so to kick things off, let me ask you a question. What in the world does your smartphone have in common with, say, a security camera or a network printer? I mean, on the surface, they're totally different things, right? Well, the answer is actually pretty simple. They all need an address to connect to anything. In the tech world, we call all these things computers, printers, phones, end devices. And just like your house needs a street address for the mailman, every single one of these gadgets needs a unique IP address to send and receive information. Without one, they're basically just sitting there, completely cut off from the network. Okay, so what is an IP address really? It stands for Internet Protocol Address, and it's basically how devices find each other and start talking. Seriously, you can think of it as a unique digital fingerprint for every single thing connected to the internet, from these huge, massive web servers all the way down to the phone that's sitting in your pocket right now. But here's the cool part: these addresses aren't just a jumble of random numbers. Nope, they actually have this really clever organized structure. See, every IP address is made up of two distinct parts, and once you get how those two parts work, you'll understand the key to how the entire internet is organized. It's pretty neat. Let's use an analogy to make this super clear. Think about how the postal service works. The network portion of an IP address, that's like the street you live on. It identifies the whole neighborhood where all your local devices are. Then you have the host portion. That's like your specific house number. It pinpoints your exact device on that street. You absolutely need both to get that package delivered to the right spot, right? Okay, that makes sense for us humans, but what about a computer? It just sees a long string of ones and zeros. So how does it know which part is the street and which part is the house number? When it looks at an IP address, how does it know where that line is drawn? Well, it uses this really important tool called a subnet mask. You can literally think of it like a stencil or maybe a decoder key. A computer takes this 32-bit value and lays it right over the IP address, and just like that, it perfectly separates the network part from the host part. This little piece of info is absolutely crucial. It's what gives the IP address all of its meaning. Now, to actually use this stencil, computers have to do a little bit of math. But don't worry, it's a super simple calculation. It might sound fancy, but it's something a computer can do in like the blink of an eye. This special math is called a logical AND. It's a really basic idea in how computers think. All it does is compare two bits, so two individual ones or zeros, to get a single result. And with just this simple comparison, a computer can instantly figure out the network's street name. And the rule for this is so simple. Get this. If the first bit is a 1 and the second bit is a 1, then the result is a 1. That's it. Any other combination, a 1 and a 0 and a 1, or two zeros, the result is always 0. You only get a 1 if both inputs are a 1. Simple, right? So here's how it all comes together in practice. The computer takes the IP address and the subnet mask, and it lines them up, one right on top of the other. Then it goes bit by bit all the way down the line, applying that simple logical AND rule. The final string of ones and zeros that it gets from doing this, that, my friends, is the network address. It's the official name of the street. And you know what? This one simple calculation pretty much unlocks everything we need to know. By using that subnet mask to find the network address, we can now identify the three most important types of addresses that exist on any network. Okay, so first up, you've got the network address itself. This is the one we just calculated. It's the starting point, and it represents the entire network. You can't actually assign this address to a single device because it's talking about the whole street, not one specific house. Second, we have the host addresses. Now, these are the ones we can actually use. These are the individual house numbers on our street. This is the range of IPs that get handed out to your computer, your phone, or your printer so they can all talk to each other. And finally, there's a special one called the broadcast address. This is for when a device needs to send a message to everyone on the network at the exact same time. Think of it like a loudspeaker for the whole street. When a message gets sent to this address, every single device on that local network gets it. So, why does any of this matter? Well, because when you put these three address types together, they create order out of what would otherwise be total digital chaos. The network address gives your local network its identity. The host addresses give each of your devices a unique spot inside that network. And the broadcast address gives them a way to shout to everyone at once. This system, right here, is the fundamental reason your home or office Wi-Fi actually works. But let's end with a final, kind of mind-blowing thought. This whole system we've been talking about, it's called IPv4, and it only has space for about 4.3 billion unique addresses. Here's the kicker. We officially ran out of those years ago. So with tens of billions of devices online right now, and trillions more coming, how is the internet even still working? And what in the world comes next? Well, that's a story for another time.